Well, so I'm just re-explaining you the working of N-channel enhancement type MOSFET. Okay. So as we know, we take a pure semiconductor, dope it with the P-type material to form P-type semiconductor. Okay, so this is P-type semiconductor. At the two extreme ends, we dope it with the N plus. Plus indicates extra doping. So these two are N-type. Right? Then a layer of SiO2 is placed on it. So this is SiO2, which acts like dielectric or insulator. Above that, we have placed a metal layer that is referred as gate. So this terminal which is coming out from this metal is taken as or is named as gate. These two are referred as source and drain. Source and drain. Fine. Next. Next what we have. Initially we don't give the VDS. We are not giving any VDS. So there is no channel formed also. Channel is not yet formed. For channel to be formed, what we do, we apply some voltage at the gate, that is positive voltage. Because of the electric field, okay, positive is capable of attracting the negative, that is electrons, and positive repels the positive charges that are holes. So these holes move away. And all the electrons which are minority charge carriers in p-type, they will be attracted here near the interface. Okay, so here I will get a layer of electrons, and this process itself is called as inversion. First it is called as inversion, and when inversion is completed, inversion is the invert. Positive negative, all negatives are attracted. And once the inversion is completed, we see that the channel is formed or the path is ready. When the path is ready, we need to just trigger or start the electrons to move from one end to the other end. Therefore, what we do later, we apply the VDS. When we apply the VDS, this positive, what it will do, it will start attracting all the electrons. So electrons will start moving like this. From source. Okay. So this source is connected to N plus and this drain is connected to N plus, which are connected to the channel. So electron movement is from left to right, or current moves from drain to source. We have seen. Next, what happens? As I increase this VDS, actually there is a depletion region. Okay. That depletion region is more on the right hand side. Why it is more on the right hand side? Because positive voltage is connected to the N-type material, which makes right hand side reverse biased. Reverse bias means the depletion width is more, and here N-type material is connected to negative, so here the depletion region width is less. As I increase this voltage, more reverse biased, so more will be the width of the depletion region. This region will increase, and when this region is increasing, it will try to overlap the channel. Channel will be engulfed by the depletion region. When there is very less space left for the charge carriers to move, okay, that condition is called as pinch off. And we represent the IV characteristics. IV it is current voltage. Current to voltage. When VDS is 0, current is 0. When VDS increases, current increases. Okay. More potential, more current. but after pinch off, the current will saturate. So this point Vp, which is called as pinch off voltage, or the voltage at which pinch off has occurred. Okay. After pinch off, the current will not increase, it will saturate. Though you increase the VDS, the voltage just request code, current will not increase, it will saturate. So if this current level is at VGS equals to 5 volts, VGS equals to 5 volts, if you increase VGS, more electrons which are present at the bottom end, they will also come in the channel. So more charge carriers, if more VGS. So if you increase VGS, the current level will be more. VGS 6 volts. Or if you decrease the VGS, channel will become weaker, or less number of charges will be present in the channel. Therefore, current level will also drop. So VGS, if it is less, the current level will drop. So VGS 3 will be here like this. This is a summary of working of N-channel enhancement type MOSFET. Okay. Okay, tell me, if you want to construct a P-channel MOSFET, what will you do? P and N will interchange. Then what will interchange? Minus and plus. Here also minus and plus. Okay. Then we have something called as threshold voltage, which you know. What is threshold voltage? Voltage required to turn on the MOSFET. Okay. Adjusting the threshold voltage is one small topic. Adjusting the threshold voltage. Suppose the threshold voltage here it is say 0.7. 0.7. Okay. You want to change it or you want to adjust it, then it is possible to adjust it. Few options are like, you can change the width of the this one oxide layer. SiO2 layer is width ಸ್ವಲ್ಪ ಹೆಚ್ಚು ಕಡಿಮೆ ಮಾಡಬಹುದು. Okay, or I am saying exactly the thickness. Thickness of the SiO2 layer can be changed, which will put a small effect on this threshold voltage. So it can be changed, say 0.71 or 0.69. If you want to change it, it can be done. And one more way of doing or changing the threshold voltage is, you can change the doping concentration in the substrate. So finally, what we are changing, threshold voltage means what? When the device should be on, that we want to change. Okay. So if you change the doping concentration, increase or decrease, okay. So channel formation timing will change. If the doping concentration of P is more, say doping concentration of P I have increased, okay. Or doping concentration of N in this is little bit increased, then it will change the timing of channel formation. Or the first option which I said you, if I vary the thickness of this SiO2, the effect of this voltage will be altered. ಇದು ಎಷ್ಟು thin ಇರ್ತದ ಅಷ್ಟು ಜಾಸ್ತಿ effect ತೋರಿಸ್ತದೆ. This voltage shows maximum effect when the oxide layer is thin. When I go on increasing the oxide layer, electric field will decrease. When electric field decreases, these electrons are attracted at a slower rate. At that time, I am increasing the threshold voltage. 0.7 Allah, it will change to 0.71 or 0.72. Getting? These are the ways of adjusting the threshold voltage of any device.